When you press play in the Unreal Engine, the game starts and you can control your character. But what's really happening behind the scenes? How does the engine take your blueprints and turn them into a playable world? In this video, we'll break it down step by step. Even if you're just starting out with game development, you should be able to follow along. We are going to talk about the order of behind the scenes events and why that's important. So for example, why does the game mode start before event begin play? This will better help you organize your code and know where to put your blueprints. Firstly, when you hit play, the engine starts a brand new game session inside the editor. The engine essentially copies everything in your level and puts it into this new world, so you can make changes and test things without it affecting your original world. This is called non-destructive testing, and this new copy that you've created is called the PIE, or Play in Editor, world. That's all well and good, but the engine does more than just copy and paste a level. The first thing it does is create a new UWorld object. The assets that are in the editor are then loaded into the new UWorld object. I know that might seem like a load of nonsense, so let's take an example of rooms in a house. Imagine you have your bedroom in your house, and you have loads of toys in your room. The UWorld is like the entire room, the container that holds all of the toys. The toys you see on the floor are the actors, already loaded in memory. When we hit play, the engine makes a copy of this room and all its toys and puts them into a new room, which is a new UWorld, so you can play without affecting the original one. The toys in your box, so your content browser, aren't moved into the new room until you actually use them in the level. They just sit in storage until needed. Here in the editor, what we are looking at now is the editor level, but when we press play, we very quickly make a new UWorld object, which is just a container for literally everything we're going to have in our world, not just actors but also game modes, player controllers, widgets, etc. Now we understand the main concept, great. But you know how I said the UWorld object contains everything? Well, there's one exception, the game instance. The game instance is the highest ranking object out of all of them. You can only have one and it persists, so stays the same, between all levels. If you close the editor, it will also close, so it doesn't permanently stay on your computer outside of the editor unless you specifically save it. But if you're in the editor, then create a new UWorld object by pressing play. Everything else is duplicated into a new copy, except your game instance, which is loaded fresh. So the game instance you see in the editor is a template off of which the new game instance is made. Here are some of the key things that you may find inside your game instance. The game settings, so for example keyboard bindings and audio volume, player profile data, for example player name or stats that should always persist between levels, or multiplayer session data, like lobby data. This is loaded in before the new UWorld because if you have a player high score for example, that can then be loaded into any new UWorld object. Changing maps would need a new UWorld to be loaded in. Think of loading a new map like walking to a new room in the house. We said that each room is its own UWorld object, however the game instance can go between any of these rooms, as you want your player's high score to not get deleted when they enter a new map. Okay, so far we have this list of events. You press start, then your game instance is loaded, then your UWorld object is loaded, then everything is loaded into your UWorld object. But that isn't done randomly. There is a very specific order to which objects are loaded into your UWorld object. So there is an order in which you move certain items into another room. Certain ones have priority and come first over others. Order matters because some objects depend on others to exist first. For example, the game mode needs to be loaded before the player is spawned because it decides what player to spawn. The first things that are loaded into our UWorld object are the game mode and game state. These are two very important things that take priority over all the others, and once I've explained what they do, you'll see why they need to come first. The game mode defines the rules and flow of the game for a specific level or session. You only have one per UWorld object, and it's in charge of things such as which character is spawned into the level, which player controller to use, and what happens when a player wins or dies. Let's take a look at Rocket League for example. The game mode would do things such as keep track of the score of the match, it would spawn the players into the level and assign them player controllers, and it would decide what to do when the player wins or loses the match. The game state is very similar to the game mode. It also holds things like score, but the difference is that the game mode holds information for the back-end server for all the logic about the game that the player doesn't need to see, whereas the game state holds things that the player will want to know. So they both might hold score, but the game mode is responsible for the stuff that the player doesn't need to know and see, like who wins, whereas the game state is readily available to pass information to the client, so it can tell you your score. To summarise, the game mode and game state are the first things that are loaded into the UWorld. They are quite similar and hold general important data, but the game mode handles behind the scenes logic that the player should never have to worry about, whereas the game state is able to communicate information to the client. So maybe tell them how many players are left in a match, in a battle royale for example. Now we can spawn the player controller and the pawn. This is where you, the character, get control of what you are doing. The pawn is the character you see walking around, and the player controller is the brain that does the behind the scenes logic to make it move. Imagine a car. The pawn is the car body, whereas the player controller is the driver behind the wheel. You'll notice in your blueprints that you have two graphs. You have the event graph, but also the construction script. After the player controller and pawn are loaded into the world, we run the construction script first and then event begin play. This is useful because you may want to configure some logic for your game to run after you press play, but before the game really starts. For example, I made an inventory system where you can change the mesh of items in this panel, yet it automatically updates. If we used event begin play, we would have to wait for the game to actually start before the mesh changes, but if we put the logic on the construction script, it will get run before event begin play starts, so it will update before the game really starts. The game essentially starts on event begin play, as the name would suggest, but there is still one event left to trigger. This is event tick. This is an event that fires every tick or once per frame and is run after event begin play starts, although it's so fast to start that you would never notice the difference. They effectively start together. This happens in this order because tick essentially updates stuff in your game, like a score counter for example, but it's assuming that the game has already started. Why would you update the score count before the game started? So that's the entire process. From the game instance to event tick, we have covered the entire process and I'll now do a quick recap. When we press start, we load the game instance, which is the highest priority item. It holds the main essential logic / information that needs to always persist between levels. Then, we create a new UWorld object, which is like a container for everything else to be added to. We then add our game mode and game state to this UWorld object, which controls the main logic for the game. Then the game mode will spawn in the pawn and player controller. But we can't play yet, because we need to run the construction script, which is the last game logic that you can implement before the game really starts on event begin play, which is closely followed by event tick. All of this happens seemingly instantly, but it's important to know the order in which things happen because it may change where you put some of your logic. For example, if you wanted something to happen as soon as you press play, like create a multiplayer session, you wouldn't actually use begin play, but the game instance. Thanks for watching. If you want me to cover any other topics, drop a comment below. You're also welcome to join my Discord to chat about game dev or this video's topic. I make these videos for free, but if you want to support me, check out my Patreon for perks like early access and exclusive assets. Goodbye.